This is Unit 8, Lesson 7, Multiplying Radicals. Let's take a look at the first example. This doesn't have anything to do with radicals, but we're going to go back to something we've learned before to use it as a model for dealing with the radicals once we get to them. 5x times 3x to the fourth. The way we deal with this problem is by multiplying the coefficients 5 and 3 to get 15, and then multiplying x times x to the fourth using our properties of exponents and getting x to the fifth. Now take a look at example 1b. It's similar in that it's 5 times a value times 3 times a value. And those values, instead of being variables, they are square roots. But we're going to deal with it in the same way that we dealt with problem 1a. We're going to first multiply the coefficient-ish. It's not exactly a coefficient, but it's a whole number value, 5 and 3. And we're going to multiply those just like we did before, 15. And then we're going to multiply the values that are under the square roots, because those aren't actually 8 and 5, but in fact the square root of 8 and square root of 5. So we would multiply 8 times 5 and get 40, so our answer is 15 square root of 40. Now, that's not simplified, so we now need to go ahead and simplify the square root of 40. You can do that however you'd like. I like to think of it as 4 times 10 because 4 is a perfect square, and so I can take out a 2 and be left with the square root of 10. So I'm going to replace the square root of 40 with 2 square roots of 10, and so we get 15 times 2, which is 30 square root of 10. So let's take a look at the next example, 5 square root of 20 times 7 square root of 12. We can do this in the same way. You're basically thinking of it as outside the radical sign and inside the radical sign, so we can go ahead and multiply the outside times the outside. 5 times 7 is 35, and the inside times the inside. 20 times 12 is 240. Now we need to simplify, and if you want to do that in the way we've been doing it already, we can use a factor ladder. And I'm going to quickly do a factor ladder over here. Lots of dividing by 2. So I've just done my factor ladder, and I can see I can take out a 2 and another 2, and I'm left with 3 and 5 on the inside. So taking out a 2 and a 2 is joins the 35 that was already out there. We're taking out a 2 and another 2, and we're left with a 3 and a 5 on the inside. So when I simplify that, I get 140 square root of 15. Now we can do this same problem in a different way. Instead of multiplying and then simplifying, we can simplify first and then multiply. So we can take the square root of 20 and realize, I'm going to write it down here, the square root of 20 is the same thing as simplifies to 2 square root of 5. And the square root of 12 simplifies to 2 square root of 3. So I can replace 20 with 2 square root of 5. I already had a 5 on the outside. So 5 times 2 square root of 5 is going to be 10 square root of 5. And then I can replace square root of 12 with 2 square root of 3. And so that would give me 14 square root of 3. Now, I wouldn't normally write this line. I could do that all in one step, jumping right down to this next line here. So now what I've done is I've taken the first line and I've simplified it. And now I'm going to do the multiplication. So we're going to get 140 square root of 15. So you can see I ended up with the same answer either way that I did it. You have to be careful because you still have to check out what's inside. It's possible that after you multiply the two radicals together, you get something that could be further simplified. So if you're going to simplify then multiply, you need to then look again at your end result to see if you could further simplify once you're done with that. All right, let's try the next one. Negative 3 square root of 8 times 2 square root of 14. I'm going to simplify this. I know square root of 8 is 2 square root of 2, so I will get negative 6 square root of 2 times I can't simplify square root of 14 at all, so I leave it 2 square root of 14. But that just makes things a little bit simpler to start. So now I'm going to multiply negative 6 times 2 is negative 12. And square root of 2 times square root of 14 is square root of 28. Now here's that case that I was talking about. Square root of 28 is now something that we could simplify. The square root of 28 is equal to 2 square root of 7. Square root of 28. Okay. We could do a factor ladder, or we could recognize that as 4 times 7. And square root of 4 is 2. Square root of 7. So I can replace that with 2 square root of 7, and so we would get negative 24 square root of 7. So if you did well with your simplifying, then this is just one more step ahead of that, and then the simplifying process is just as we learned before. All right, example 4. I'm going to multiply outside times outside, inside times inside. So the numbers outside are whole values, 3 times 7, that's 21, and the numbers under the radical, I can multiply. 5 times 15 is 75. C times c squared is c to the third. So now we're left with a problem that can be further simplified. We could factor ladder it, or you could recognize that square root of 75 is the same as 25 times 3, which is 5 square root of 3. So I'm going to simplify square root of 75 to 5 square root of 3. I'm going to multiply 21 times the 5 and leave the 3 on the inside. And then I'm going to look at the c to the third power. I'm going to say, oh, square root of c to the third. I can simplify that and pull a c to the outside and a c on the inside. Again, if that's confusing to you, what I was doing with that c, go back and look at the simplifying radicals lesson. All right, so we're going to go ahead and then further simplify by multiplying 21 times 105 times 5 to get 105c radical 3c. 105c radical 3c. All right, here's another one. In this case, the second radical has no whole value on the outside. So it's as though there's a 1. So we're going to multiply 6 times 1 and get 6. Oh, I'm going to erase that. All right, this one looks pretty complex, and I recognize 32 and 300 as some values that could be easily simplified. So I'm going to simplify first. I'm going to first simplify square root of 32, and I recognize that, again, as a nice, simple, perfect square, 16 times 2. So that's equal to 4 square root of 2. Square root of 32 is equal to 4 square root of 2. So the numerical part of that is going to be 4 times 6 is 24. And we're going to have a 2 left on the inside. And then I'm going to look at each of those variables and simplify them. X to the third, I can remove an x and leave an x on the inside. The y is too small. It's only one value, so that's going to stay on the inside. Z to the fifth can have a z squared on the outside with a z left on the inside. Again, if you're unsure about how to deal with those variables, go back and look at the lesson on simplifying radicals. All right, next one, square root of 300. I'm going to recognize square root of 300 as another number that has a very obvious perfect square factor, 100 times 3. So that's equal to 10 square root of 3. So the numerical part of that is going to be 10. I'm going to leave a little bit of space, put my 3, and then I'm going to deal with the variables. X squared, the square root of x squared is x. Put that on the outside. Square root of y, we can't simplify further, so we leave it as y. So that's a little bit easier to deal with. Now I'm going to multiply the two values that are on the outside. 24 times 10 is 240. X, that was 24 times 10. X times x is x squared. Z squared, there's nothing on this side that's a z, so we leave that z squared. So that's on the outside. And then on the inside, I'm going to multiply 2 times 3 is 6. x y squared z. All right, so let's take a look and see what we have. Now we have to decide, could I simplify anything further underneath that radical? And you can see that there's a y squared here that I could simplify. 6 can't be simplified any further, but the y squared can. That's equal to y. So I'm going to rewrite 240 x squared. Then I'm going to insert in the newly simplified y, z squared, square root of 6xz. So it's important that you write both on the outside and on the inside your variables in alphabetical order. Good luck.